Hello, class. This will be the recorded lecture for section 10.2, and we're going to talk about calculating confidence intervals with two proportions using technology. So what we did last time, let me pull up, and we're going to do the same calculations using technology, but this is what we did in the last recorded lecture. This idea of high ozone levels with children. One was 50 in a high ozone layer or location, and one was in a lower level ozone location with 80. And we did a 95% confidence level with our X values of 14 and 12 respectively. And so I went through this calculation on the whiteboard. Again, just to reiterate it here, our point estimator or estimate is P1 minus P2. Both puts hats on top, right? And so when you do that calculation, we ended up with about 13%. Just like we did in a one variable confidence interval, if you're using z-scores, you just find the right one, and this one, the 95% off the table, off the spreadsheet, et cetera, is 1.96. The standard error, as it looks like, just like in the last section, we calculate the standard deviation using the central limit theorem of both the first and second experiment, add those together, and you can see that this is our standard error. And then our margin of error is the z-score times the standard error, and we ended up with a little, almost 15%. So when you find your confidence level, the lower bound and upper bound, you could see that the lower bound is negative. And I did not explain this in the previous lecture, so this is important, is that the confidence interval contains 0, which means there's no difference between experiment 1 and experiment 2, which typically is not good. And so what you could say in this case is that it's in a 95% confidence level, you could have 0 difference between the two, right? So we can't be sure that the proportions of children diminished lung capacity differ between the two communities. If your confidence level is different, you might be able to make a different conclusion, but not at 95%. As you can see, we went below 0 there. So that's an important concept with regards to this. So technology. So one of the things that you could do is use your fancy calculator, and it's called 2PropZInt. And basically type in the X1s and N1s and X2s and N2s and the confidence interval. When you type that in, you want to do it as a decimal, it looks like. And then you calculate, and out comes your confidence level. And you could see that it's 0.017 and 0.2201, just like we calculated by hand. Unfortunately, it doesn't give you the standard error or the margin of error. So it's important to understand how to do these by hand as well, in my opinion. So what did I do for you? Well, what I did here is, let me make it a little bigger, is I generated this spreadsheet, and this is for chapter 10. And if you remember from the recorded lectures, for those of you that listened to it, I generated this spreadsheet that calculated that crazy degrees of freedom when we were doing the t-scores with the independence of two sample means. And so this one was quite a bit easier, but just to show you that you can use spreadsheets and program it the way you want. If and when any of you have to do this by necessity. When I was growing up as an engineer, we didn't have a lot of computer-aided design at the time. And so I did a lot of my analysis right on the spreadsheet. We did a lot of what if scenarios of changing values, seeing what happens, and I got really good at programming the equations into each cell. So that's what I did here again for you. So let me show you what I did. So here is X1, N1, X2, N2, and here's the confidence interval. Make sure you put the confidence interval in as a number. So 95% would be 95, 90% would be 99. All these are formulas. So this will calculate your P1, P2, the appropriate Z-score for your confidence interval, your standard error, your margin of error, point estimator, and then your lower and upper bound. So it's kind of nice because then you could do what if scenarios, right? Say like instead of X1 being 14 out of 50, it was 20 out of 50. Oh, now you can see everything has changed, and you can see now the margin of error changes slightly, your point estimator changes a lot, and now you can see that the lower bound and upper bound changes. So it's really good process to do what if scenarios again, and that's what we did in my engineering life. All right, if we change this inductor from 5 millihenries to 10 millihenries or whatever, what happened to the circuit, we would do what if scenarios like that using spreadsheets. Now you just use computer aided design, but you could see the power of this. What's nice is that you could change the confidence level. The Z-score will change for you right away, and your margin of error and your lower and upper bound will change too. So like we say, okay, we don't want a 95% confidence level, but we want a 90. So if you change that, you see, boom, everything else has changed. And you can see the lower bound now goes above zero. Still real close to zero, right? So still not that confident, but you can see it does. You know, if you went down to 80%, it probably will go up a little bit more. And now you see that the lower bound goes to 3%. So you can see you could do a lot of nice what if scenarios in this case. So in the recorded lecture section of our Canvas site, I will upload this spreadsheet. So you will all be able to download it and use it not only for your homework, but also kind of take a look at how these equations are generated. And for those of you that are interested in generating these equations, moving forward, if you ever have another math class, or more importantly in the real world, hopefully that'll be a useful type of exercise for you. So that ends the recorded lectures for section 10.2.